Okay, our next topic is applications of polynomial equations. In this section, in this topic, we're looking at problems that make use of solving quadratic equations or working with. I said quadratic. Real quickly, so I don't confuse you. A second-degree polynomial equation is called a quadratic equation. So when you hear me say that word quadratic, that's what I'm talking about. More specifically, second-degree polynomial equations. That's mostly what we're going to deal with when we talk about applications. We can talk about higher ones, but for the most part, we're going to be focused on second-degree equations. Now, the word application is math code for word problem. Word problems, we reach up to some higher levels of thinking. We take what we've learned and now we apply it to create and evaluate. We're getting up to this higher level thinking skills, and that's what makes them harder for your students, is that we are dealing with those higher level thinking skills. Our application problems really come in one of two varieties. In the first type, you're given an equation, right, and then ask the questions based on that equation. Typically, these problems would involve, they tell you one of the unknowns. You usually have two unknowns in these problems. You're given one of them and need to use that equation to find the second one. The second type is you need to write an equation. And so in those examples, you're given information. You need to use that information to come up with an equation. They're typically a little bit harder because you have to actually come up with the equation. And we'll see some different examples in our various problems. In this section, there's examples of each type. We're going to begin with this example. So here's our first question. A rock is thrown up from the top of a 160-foot building at a speed of 144 feet per second. The height h of the rock, t seconds after it is thrown, is given by the equation h equals negative 16t squared plus 144t plus 160. So this is our equation. Here we're actually given an equation in this problem. But now it's really important to work with this equation that you pick out some important information. Specifically, in this problem, what does h represent and what does t represent? What is t and what is h in this problem? I'd ask you to pause the video for a moment and take a moment and think about that, and we'll go over it. So we see here that the height h, and height was already given in the problem in units of feet. So from that we conclude that h is the height in feet. More specifically, feet above the ground level. So h is the height in feet above the ground. And then what about time? Well, it says it's thrown, the height of the rock, t seconds after it's thrown. So from that we get two things. T is the time, and seconds after it is thrown. So in addition to the equation, this information right here, what t is and what h is really important. Without it, without having that understanding, you're going to have a really hard time doing the problem. So it's very important to take time and work that out. Now with that, we can ask some different questions about this rock that we're throwing. We could ask, for instance, how high is it after 2 seconds? So here we recognize 2 seconds as being the time, and we want to find the height, the h. Now recall our equation is negative 16t squared plus 144t plus 160. And so we're being told the time is 2 seconds. So we can go into our equation and plug in 2 for the time, or 2 for t. Right, and then we just need to work out that arithmetic. And when we do so, we find that the height is 384 feet. Another question that we could ask, so it's actually higher now, and it kind of makes sense. We threw it up, so we are going to make it initially get higher, but eventually that object has to fall to the ground. Right, unless we threw it high enough to get it out away from the earth, it's going to eventually hit the ground. So we might ask the question, when will it hit the ground? Not the building, but when will it hit the ground that's below the building? Well, anytime you're dealing with a problem like this, there's our equation. Anytime you're dealing with a problem like this, we need to know either h or t to figure out the other one. So although they don't come right out and say it, we want to know the time, so we need to figure out the height. So we need to know the height. Well, if it hits the ground, its height is 0. And so we can put in 0 into our equation. And we now have an equation to solve. Now that equation has some big numbers, but fortunately I recognize real quickly that 16 will go into all three of those numbers. And then I notice one other thing. My t squared term is negative, and all the problems we factored, the t squared term was always positive. So I want to get rid of that negative sign, and because this is an equation I don't have to factor, I can just divide the equation instead of factoring. And the advantage is now that I don't have to worry about that 16 laying around. So as long as I divide by a non-zero number, I can do that. Okay, and so we divide everything by negative 16. That'll change the sign there and make that a t squared. That'll make that a minus 9t and a minus 10. And now we're left with solving this equation by factoring. Fortunately, it's one that's not too bad to factor. So I ask you to pause the video for a moment, solve that equation, and then unpause it and catch up with me. So this would factor as t minus 10 and t plus 1. And that leads us to our two solutions, t equals 10 and t equals negative 1. Now in applied problems, we do have to think about our answers. Those are both solutions to that equation. But think about this for a moment. T equals negative 1. What would that mean? T was the time that after we threw it. So 0 would have been the instant we threw it. Negative 1 comes before 0. So negative 1 would actually be telling us that this thing hit the ground before we threw it. Okay, that does not make sense. Oftentimes negative answers won't make sense, but don't just immediately cast them out, because there could be some problems where a negative answer could be a valid answer for the word problem. So that leaves us with only one answer, and that would be t equals 10. Okay, it's after we threw it, so we have to accept that If we did everything correctly, then that answer is correct. Okay, so this is our introduction to these types of word problems. There are other examples that you'll find as well.